Hello, everyone. Let me just share my screen and then we can kickstart this session. All right, let me know if you can see my screen.
Yes, we can see your screen.
All right, great. So today's session is about TensorFlow and using TensorFlow for AI. A little bit about me. I am currently working as a tech lead, machine learning at Red Buffer. Red Buffer is basically an AI services-based company. So we give AI services to clients in Pakistan, Europe, and mainly in the USA. I am also a Google developer expert in machine learning and a tech blogger on Medium. So today we will talk a little bit about my story of how I am where I am, and then we'll do a deep dive into TensorFlow, and then we'll take any questions that we have. So just a little bit background of where I'm from. So I'm an electrical engineering graduate from NAST. My final year project was basically in rehabilitation robotics, and that's where basically I got interested in artificial intelligence a lot. This is back in 2016. And that's when I basically, as I like to call it, jumped off the cliff, where I left, you could kind of say, left the electrical engineering enthusiasm and jumped into machine learning. And I started learning machine learning, did a lot of self learning, and I remember that one of the first things that I did, and I volunteered for a research that had to be done on Facebook's and Netflix ranking and recommendation system. And so I started studying about that for that research, and I became more in awe of what AI could do. And so I took a lot of courses. I learned ML, and I like to call myself pretty much an VUNG build ML enthusiast. So later, I became Pakistan's first Google developer expert in machine learning. And since then, I have been affiliated with them. And I'm also the first female machine learning GDE in Southeast Asia frontier region. So that's 4 countries. That's Pakistan, Bangladesh, Sri Lanka, and Nepal. Since then, I have given multiple workshops here in Pakistan, given several talks, and have also had international presence, fortunately, in the Philippines, Sri Lanka, Bhutan, Malaysia, etc. I'm also a mentor at Google Women Developer Academy. So I've been a mentor with them for thrice, and I'm currently a mentor for Road to GD program by Google. So we're going to start off with a little overview of the potential of machine learning and and we're going to talk about 2 examples here to basically explain that potential. And then we'll jump into TensorFlow. So one of those examples is language independent segmentation of different areas based on vision. So one of the ways of separating out important information from documents is that you split that document into logical sections first, and then from those logical sections, you extract the text and you apply natural language processing, and you basically um, get the results. So for example, you have contracts, right? You have legal contracts and you want to extract important information from those legal contracts. For example, the price agreed on, the two parties, the clauses, and different kinds of things, the dates, etc., etc., and some other important information from those contracts, depending on the type of contract that it is. Normally, what would happen is that a person would basically go through that contract and figure out the important things and extract those and write them down somewhere, maintain a list of that. But if you have, for example, like a 10 pages or 15 pages PDF, it's going to take you, for a 10-page PDF, for example, it's going to take the person at least 7 to 8 minutes to go through it and to, extract the important information. Given that it's not just dates and prices, so those are figures and you can quickly figure them out, but it's other information that you need to extract from those contracts. But you can build a machine learning solution around it, right? That does that, that solves the problem and extracts the information for you, depending on the training of that model, right? And in comparison to the 7-8 minutes, you would basically have like 30-40 seconds for a 10-page PDF by the model, and followed by like you can have a manual review, but you're reducing down that time from 7-8 minutes to under 2 minutes, right? So single PDF versus a 15-page PDF through AI in the same amount of time, right? So you've increased the efficiency based on speed here, right? And for example, similarly, there's another problem where we want to install solar panels on rooftops, right? So for installing solar panels on rooftop, how this normally goes is that you have to send a team to the house, and the team looks at the roof, they look at how they take the dimensions, they do all of those things, and they figure out which areas are the best, taking all the factors into account, the direction of the sun, whether there are trees or not, and what would be blocking the sun, the sunlight, and depending on all of those different factors, the shapes of the roof, they come up with a plan of where to install the solar panels. But if you want to do it, for example, for 10 houses, it would take you weeks to do that for 10 houses, right? Because you need to send a team to each of those houses and go through the process of analyzing all the factors and coming up with the best possible area for the solar panels. So this problem can be solved by basically using artificial intelligence and computer vision. So you can take the satellite imagery, you can build models to segment the roof areas into these logical segments, as we can see on the extreme right. And you can take into account the trees, all the other factors, based on the location, the directions of the sun, and all of those accounts. And you can come up with a plan through artificial intelligence for the best areas for the solar panels. And in this case, what we're basically, so artificial intelligence can basically solve impossible problems that seem impossible to human beings, because if, for example, we take into account, we want solar panels on all houses in Islamabad, right? So that's too many houses, right? And imagine how much, given that you only have, for example, 10 people who would go, who can go out and do the analysis, etc. How much massive time this would take to basically come up with the best areas for solar panel installations for each of the houses, right? So in comparison to that, if you have artificial intelligence doing this for you, it'll probably do that for a whole of Islamabad within a day or two, right? And so AI can achieve speeds which are not humanly possible. So that's why it seems like AI can solve a lot of impossible problems, right? That's why they call AI the new electricity. They call it like the fourth industrial revolution, because it can achieve speeds which are not humanly possible, right? So TensorFlow is basically a framework which it's a powerful machine learning framework. So that's, for me, that's the USP for TensorFlow, because it's pretty powerful machine learning framework, and it has a huge community backing it with open source projects, with new tools that come up in, which making life easier for engineers who are using TensorFlow. So it's by Google. They have a TensorBoard and TensorFlow Lite. We'll see what those are. They're better for production models and for scalability. Very well documented, well-written tutorials on the internet. And TensorFlow is used in both research and industry. And they've designed it in a way where you have APIs that you can use for quick model building, and then you can also dive deep into writing your loss functions yourself, and defining classes yourself and all of those things. You can have parallel execution across multiple GPUs. Its speed is good for high performance, so it has all of these plus points in it. So a lot of companies are using TensorFlow. Google is using TensorFlow in almost all of its products. RankBrain is one of those. So RankBrain is basically the ranking algorithm that when we write a search query on Google, so the search results that we get on Google, that the algorithm that's used for it, that's the RankBrain algorithm. So we also now have cloud TPUs where we can use TensorFlow for very high bandwidth memory programs, right? So this is an overview of the different modules, the different, basically an overall picture of TensorFlow. So we have TensorFlow datasets. So this can be used to create the data pipelines for your models. We have Keras. Keras is where you can use different kinds of easily build models in TensorFlow. And there are already a lot of model architectures that are also in place that you can directly use. We have training distribution strategy in TensorFlow. So you can basically run your models on CPUs, GPUs, TPUs. You can use Google Colab for that. If you can build your models in the Colab notebooks, and you can run directly in the CPUs and GPUs. You have TensorBoard for the analysis of your models. You have TensorFlow Hub, where you can find a lot of models that you can directly use without having to write the architectures for them yourself. You have TensorFlow JS, so you can build your models right in your browsers, run them in your browsers. You have TensorFlow Write, so you can run your models on Android, iOS, Arduino, and on a lot of other devices, micro devices. And then you have TensorFlow Serving. So this is how TensorFlow has basically broken down TensorFlow into different flexibility units, right? So you have for new users, so the new users can build simple models just by using their sequential API and the built-in layers. So you can simply use a TensorFlow Keras directly, and you can build simple models through that. And then you basically have the functional API where this is a little more complex than how Keras is. So you can use the function API and the built-in layers for more complex tasks. And then you can also write your own custom layers if you want more control. You can write your custom layers. You can write your own custom loss functions, custom metrics. And then for researchers as well, they can basically write everything from scratch. So from scratch, basically, sort of like how you building things from NumPy. So you can do that, build everything from scratch. Their back propagation functions, all of the functions and classes. So that's for researchers. But Keras, TensorFlow's Keras API, I think that's the way to start. And basically, that's most commonly used, even in industry as well. So we look into one example, the cache recognition example, and how TensorFlow can be used to basically solve this problem. So for example, we have 10 rupee notes and 100 rupee notes, and we're trying to build an application for the visually impaired so that they can identify which note they're holding in their hand. So in that case, obviously, there could be multiple ways of how they're holding the different rupees. And so the first thing that you would do is obviously collect as much data as you can for distinguishing between the different notes and the different ways that it can be held in the hand. So here we're just looking at two examples. So the 10 rupee note and the 100 rupee note. This can obviously also be extended to 50 rupees, 20 rupees, etc. One of the great things that you can do in TensorFlow is that you can just split your data into folders. So normally how you would have that in your laptop. So you can just create a directory where you can have a training folder, a testing folder, and you can have for each of the classes, right? So for each of the different predictions that you want. So here we have 10 rupee note and 100 rupees note. So we have two classes, which are 10 rupee notes and 100. So you can create folders for them and then just dump the images in each of those folders, right? So now we have this directory structure, and we can directly use this to load the data into our models. And we can do augmentation on the run. So we wouldn't have to do augmentation beforehand. We can do directly, or TensorFlow would do the augmentation for us. For example, rotating the images, zooming them, cropping them. So all of those things, TensorFlow can do that on the run. So the advantage of this is obviously that TensorFlow takes the workload off of your head. The second advantage is that you can experiment with different types of augmentation. So one of the augmentations you can experiment with is rotation. And you can define the different kinds of augmentation that you want. So maybe in this case, rotation would help, but shear may not help, right? And zooming may help, but another type of augmentation may not help. So you can define which type of augmentation you want, and a TensorFlow would do that on the run for you using image generator. And that's one of the things. So you get to experiment with different things and see which one of those basically help in your model, right? So what's the best way of solving this problem? So the best way is basically obviously to start off, since this is an object, this is a vision problem. So one of the best ways to start off with this is to use the data that transformed AI research. So that's the data where we have 3.2 million images. And this is the ImageNet data set, which has a lot of data and a lot of different kind of features that models which are trained on ImageNet understand and are trained on. So one good thing that we can do with this is basically use pre-trained models, right? Models that are already trained on ImageNet, and then train them for our own classification problem. Since we have two classes and we're trying to classify image, so this is whether, into whether this is a 10 rupee note or 100 rupee note. So this is a classic classification problem. So we've already made images directory, and then basically we can use the image generator functions in module in TensorFlow. And we would basically give it the path of the image directory, and it would load the images directly from that. So based on how many folders you have in your directory, it will know how many classes there have to be. So if there are two folders, which is the 10 and the 100, so it would automatically know that there are just two classes, the 10 and the 100. And basically then you can use the pre-trained model, which is trained on ImageNet, and that would help improve and speed up the process of your model training, and also help in improved accuracy. Because the model which is trained on so many images would understand a lot of features in the images, right? For example, background versus foreground. So things like these, those models would already understand. And then when you would retrain them on your problem, so this would basically help speed up the process and also give you a more improved accuracy. This is how your accuracy graphs may look like. So training accuracies versus validation accuracies, and then you can analyze your models using the training and the validation accuracy plots, and also through confusion matrices of how much of your classes are being confused. How many 100 rupee notes are you confusing into the 10 rupee note, and vice versa. And then you can obviously, for the cases where you are not classifying them well or confusing them well, you can separate that data out and try to figure out the similarity in that data. Is there like a particular type of data which is being misclassified? So you can go back and basically try to understand those things. and then change your model or make adjustments in the data and retrain the model and repeat those processes. This is where TensorBoard comes in very handy because you can, using just 2-3 lines of code, you can also link your code model training with TensorBoard, and what would automatically happen is that you can look at the images, the sample images in your data set right in TensorFlow, and most importantly, you can see how the loss, you can see live the graph for the loss and the accuracy inside TensorBoard. So with every iteration, you can see how the loss is decreasing, how it's not increasing. And obviously you can also, if you feel that, you can see if you feel that the loss is not decreasing and the model is basically, if you spend another hour letting it train, you'll be wasting your time. So you can obviously stop the training and then redo all of it as well. Obviously, there are other methods for it as well. For example, you can use early stopping. So early stopping methods you can use in TensorFlow as well, which are also a few lines of code. And you can define basically, okay, if I reach 90% accuracy, the model should stop further training in order to not overfit. Or for example, if my loss has decreased below 0.05, so I want the model to stop training. Or to save the model, a version of the model. So you can do multiple things using early stopping. Then we also have TensorFlow Lite. So TensorFlow Lite, you can run machine learning models on your mobile or embedded devices with low latency and a very small binary size. So the way to do this is obviously how it goes, like as an overview, is that you train your model, you convert them to TensorFlow Lite, and then you can run them on either Android or iOS. So let's look at one example. So basically in this example, they are taking sensor values from the Arduino, the motion sensor values, and then the values from those motion sensors, the TensorFlow model is built to classify what motion is being made, right? And then the model basically classifies the movement into one of those motions. And then we have TensorFlow JS, where you can build models in and run them in the browser. So one example for that is PoseNet. PoseNet is basically a model, an already built model, which detects poses. So it detects these stick figures in a person. And there was a very interesting and fun application that was made by the name of Move Mirror. So what was happening in this application was that they had a directory of a lot of images. And for each of those images, they had identified already what pose is present in that image, right? And then you can turn on your webcam, and as you're moving, so your pose is changing, and as your pose is changing, so the images would change, and that would basically create a GIF. You can look into an example for that. When I put it on the track, when I see a shake that, when we hit it from the back, now you're gonna love that. Really just come get on the floor like that. Get it up, cause me want some more like that. Me a crazy fool. So much friends take you back to school. For them every season like 1, 2, 3. So the DJ clap up back to me. Run it, now run that track. Now run it, now run that track. All night and now run that track. Okay, all night, now run the track. Boy, run it, now run that track. Now run it, now run that track. Run it, now run that track. Now run Okay, so lastly, we're going to see just some problem solving ideas with TensorFlow and what kind of different packages or different models can be used for different kinds of problems. So one interesting thing in TensorFlow is TensorFlow similarity. So this is a Python package for finding similarities between images. So for example, we have here a data set of different kinds of cats and different kinds of dogs. And what TensorFlow similarity would help you do is I basically cluster the similar images out. So for example, here it would understand that this is cat 1, so this is cat 2, and then cluster separately the dogs as well. So if you would see them on a graph, so the cat's images should be closer together and the dog's images should be closer together, and then they should also be, the cluster should also be away from each other. So here as well, we can see that the cats are clustered together and the dogs are clustered together as well. And then similar dogs are clustered similar together. So TensorFlow similarity can be used, for example, to solve problems like identifying similar diseases, right? So if you have a database of a lot of different images and you want to classify, you want to separate them out into similar types of diseases, so you can use TensorFlow similarity there. At the same time, if a new person comes in and they have a certain kind of skin disease, you can obviously take a picture, for example, and then using TensorFlow similarity, you can pick out similar cases of that same skin disease. And maybe the doctor can run through those similar cases and to figure out how to solve the current skin problem or take help from those similar cases, right? So that's one place where TensorFlow similarity can be used to assist doctors. Similarly, there's another problem that's currently going on, which is protecting Australia's coral reef. This is a competition that they launched on Kaggle, where the purpose is, the problem is that there's a certain species, there's certain kind of starfish which basically eats away coral reefs. And coral reefs are obviously important for a lot of other species underwater. And because of the overpopulation of that certain kind of starfish, the coral reefs obviously get eaten away, which affects the other species underwater. So they want to basically identify using underwater videos how many starfishes are there and where are they exactly, and basically keep a count of them so that they can keep a track of overpopulation of starfish, and then obviously use that to protect coral reefs. So wherever there would be like an overpopulation, they can see that there's an overpopulation going on for starfish in this area. They can take methods and actions to protect the coral reefs in those areas. So this is a majorly an object detection problem. So this is a coral reef, and this is the kind of result that they're hoping to look for. So like you have a video where you're looking over at the surface underwater, and you can identify where the starfishes are and how many there are. So in this case, for example, we can see 4 of those detections, right? And then we also obviously can do time series prediction using TensorFlow. And one of the, for example, problems that we can solve with this is based on nutrition intake. So we do know that for a lot of countries, nutrition intake is very important. So if you have, for example, the nutrition intake for a person on a daily basis, and you want to make sure that they're staying healthy, their intake is healthy, so you can use a time series to basically predict when a person may go into the category of low nutrition. So given their past history on nutrition intake. So that's where time series in TensorFlow can also help figure out and identify which people in a group of people may be moving towards low nutrition, or identify basically the health of different people. So we can also use time series for, so time series can be used wherever we have historical data, right? So you have historical data, timestamped data, right? And you want to use that historical data to predict how the data would look like in future, right? And based on how the data would look like in future, you can make certain judgments, right? So for example, in case of nutrition, you can look at the past historical data of intake for that person and how judge, predict how it would look like in future. And based on how it would look like in future, you can make certain, you can classify them as low nutrition, medium nutrition, etc. So similarly, we can also use time series to predict electricity consumption, to predict nutrition intake, to predict petrol consumption, sunspot activity. So this is related to NASA in space or predicting revenues. So it can be used for all of those problems, solving those problems as well. So that's about it. Would love to take any questions.
Uh, Aqsa, can we use TensorFlow with the React, yeah, Next.js?
Sorry, I can't hear you properly.
Can we use Next.js with the TensorFlow?
I'm sorry, I still didn't understand. Can you type that in the chat? So I
Yes,
guess
I
what we
typed.
can do is that you guys can type your questions in the chat and I can start to answer them, right? So we can take about 5 minutes for everybody to type their questions in the chat.